Hi folks, we're going to take a look at number 10 from the Unit 6 assignment. So here they ask us to use two methods to find the axis of symmetry of this quadratic function. All right, so I suppose the most direct way of doing that is to complete the square. And in the process of doing that, we're going to get the vertex, and in particular the x value of the vertex, which gives us the axis of symmetry. Okay, so let's start with that. That'll be our method one. So y equals, so of course to complete the square, our first step is to factor out anything in front of the x squared. So I'm going to factor out this minus 2. And what are we left with? We're left with x squared, and 16 divided by negative 2 is negative 8x. And then of course we have the minus 24. All right. So here, next part is to complete the square. So I'm going to write this as minus 2 times 4x, and so I have to add and subtract 4 squared. All right, and so now I have negative 2, and the first three terms here are what give me my perfect square. So that's going to be x minus 4 all squared minus 16 minus 24. Now, in the end, the only thing I have left to do is to redistribute, simplify, but I'm not actually interested in the minimum maximum value. The only thing I'm interested in is the axis of symmetry. So certainly if I wanted the y value of the vertex, I would keep going. But here I have that the axis of symmetry, okay, is just given by, now remember, the axis of symmetry is a line, so giving me a number doesn't get you full marks. You actually have to give me the equation x equals 4. All right. So again, the only reason why I'm not continuing here is because I already have the information that I need. All right, so let's look at a second alternative. Okay, and a second alternative is to find the x-intercepts of this function and then average them out to find the average axis of symmetry. Okay, now if we want to find the x-intercepts, presumably this is going to be easily factorable. Okay, because otherwise I would have to find the vertex form, then replace y by 0, and then solve for the x-intercepts. It would be a waste of time since we would have already had the axis of symmetry. So let's try factoring. So since I'm looking for the x-intercepts here, y is going to be equal to 0. And here I notice that there's a common factor amongst all the terms. So let's factor out the negative 2. And I'm left with x squared. 16 divided by negative 2 is negative 8x. And then negative 24 divided by negative 2 is plus 12. And that leaves me with a nice trinomial to factor. So here, negative 2, and here, two numbers that multiply to 12 and add up to negative 8 comes right away. It's just negative 2, negative 6. So x minus 2, x minus 6. So the x-intercepts, I can just read right off the equation. So what makes x minus 2, 0? 2. And what makes x minus 6, 0? 6. And so here, to find the axis of symmetry, I just have to find the h value of the vertex, which is just 2 plus 6 divided by 2, which is 8 divided by 2, 4. So x equals 4. Okay, luckily I get the same answer. If I didn't, I must have made a mistake somewhere. Okay, so just keep in mind that to find this information while completing the square is great, but sometimes when factoring is easy, it might even be faster to go in that direction. All right, that's it for this one.